Good morning and good afternoon, everyone. Thanks for taking the time to join us in today's webinar, The Future of All-Flash Arrays. Today we are joined by Henry Balthazar, Senior Analyst at Forrester, and Shahal Feinblit, CTO at Caminario. Before I hand it over to our presenters, I'd like to remind you that we try to keep these sessions as interactive as possible. So please be sure to enter any questions or comments into the questions console of the GoToWebinar platform. We'll have time at the end to answer these live. And now, without further ado, let's go ahead and get started with Henry, who will share his insights of the industry.
Thanks for your time today. My name is Henry Balthazar. For those of you who haven't met me, I am the lead storage analyst at Forrester, and I'm in charge of covering storage technologies at my firm. So that includes storage systems, storage management software, cloud storage, and of course Flash, which is what we're going to be talking about today. So for today's agenda, it's pretty basic. We're going to start out basically talking about, first thing I'm going to go over is some of the enterprise challenges that we're seeing. And this is all based primarily on the inquiries that we do with our enterprise customers and the types of issues that they're bringing to us and asking us about. After that, we're going to spend some time talking about what are some of the key attributes you should be looking at if you're shopping for an all-flash array or if you're looking to try to take advantage of solid-state storage in the future. And finally, in the last section, we're going to talk about recommendations, things to look at as you evaluate the space, and also what customers should be looking at going into the future. I think one of the other key things here is, a big point of emphasis for us and myself going forward is, I think a lot of times we get caught up in speeds and feeds and those types of metrics and all the different, and usually that's a lot of the marketing we see around all flash arrays. Ultimately, what I want to get to is a point where we start looking at business value and how flash arrays can enhance the business value of your company, how it can advance revenue opportunities and improve customer experience and other aspects like that. And that's what we're going to be talking about towards the end of the presentation in terms of, performance is great, but what's more important is what performance can do for your business going forward. So when we look at the market today, the main things we see are, I think right now is probably the most interesting time in storage. I've been covering storage for the better part of 20 years now, but this is really the most interesting time in the market because of, not only because of the advent of a lot of the new innovations like cloud storage, new innovations like all flash arrays, and new innovations such as software-defined storage and other aspects like that. Beyond the new innovations, what's interesting is the market's changing because customer expectations are changing. I think that's a key thing to remember as you look at environments going forward. For example, today, while we're looking at we still have the same core basic problems in storage in that organizations are storing more and more data for every business operation. So even if you don't have a big data deployment, even if you don't have a video deployment or any of these other interesting use cases, you're still going to wind up having a big storage problem because data is growing within your environment, and for the most part, customers are struggling to deal with the growth and also struggling to deal with the retention. What also makes this matter worse, which is what we're going to be talking about very shortly, is the fact that when we talk to customers, the majority of them do not see are not expecting to see an increase in budget. So despite the fact that they're seeing tremendous data growth, they're not going to be getting the budget in the future to bail them out. So it's about going forward, you have to make really strong decisions. You really have to make tough choices to start finding out ways to get more out of your storage spending. So you need to be able to spend your money efficiently to get the right level of performance, right level of capacity management, right level of data protection, all within your budget while also dealing with data growth, which is going to be very, very difficult going forward. And I think the other part about this, and that's really the traditional use case for storage, and it's really been the problem that we've dealt with storage for 20 years. What's more important now, though, and it's become more evident with our inquiries, is the fact that customer expectations are changing very, very rapidly. Right now, we're seeing end-user customers, partners, and business stakeholders. They want to have higher performance because their requirements are being driven up by virtualization and the advent of new workloads. Right now, it's not enough to just deliver a storage resource, that storage resource has to have high performance and has to have consistency, to be able to meet the demands of customers today. Another key aspect is, more and more workloads are considered critical. So while we talk about flash arrays and solid-state storage and the future of performance, at the end of the day, you can't jump into that world without having the same level of enterprise-class storage data protection and data management capabilities. So it's still going to be very important to have key functions such as snapshots, replication, thin provisioning, and other things like that. So when I look at basically the inquiries I've had in the past year, one of the biggest changes we had was, about 2 years ago when we had the inquiries, performance really wasn't a big issue, but in the past year alone, we've seen a fourfold increase in performance-oriented inquiries from our customer base. So right now, it's to them, a lot of people are struggling with performance, and I think to me that's also because of what's going on with virtualization, which is what we're going to talk about in the near future. Because of the consolidation that we're trying to attempt to do with virtualization, it becomes more and more important to deliver consistent performance because, as you're trying to manage these multiple workloads, if you can't keep up with demands, you wind up creating problems for multiple workloads that are sharing an array, which is very, very difficult. As we look at here, not really too much of a surprise, there's also a huge amount of interest in software-defined storage and customers who are trying to navigate their way around clouds, so both public cloud and hybrid cloud opportunities. Yeah, this is just to highlight what we were just talking about earlier. For most customers, for a large part of customers, 40% are going to have the same budgets, and 7% are actually going to see a decrease in budget, which is almost hard to believe given the times we're at today. For the majority of customers, very few are going to get more than a 10% or 5% increase in budget. I think this is a huge issue because when we talk to enterprises in general, most of them are growing at about 20 to 40% per year, which is why I put the average about 30% annually. We do get occasional outliers. So I talked to a financial services company that had about 70% growth one year, but that was a bit of an outlier, and that was driven by a compliance event. In general, most businesses in their steady state are probably going to be still growing around that 30%. But when you look at that differentiation between 30% data growth and most customers not really getting more than 5 or 10% budget increases, it becomes very evident that we have to change the way we do things and we have to make things more efficient to create a sustainable environment. Next section we're talking about is more and more applications are being considered as critical. Only 29% of respondents said that their applications were non-critical. And non-critical applications tend to be things like test and dev and other applications that are important but really don't impact the business if they go down. What's more scary is the fact that, for both business critical and mission critical, customers said that was about 36% of their workload. Mission critical, by Forrester's definition, are workloads that if a workload goes down, that business goes down. So probably the operations platform for a utilities company, some of your important ERP type technologies, transaction OLTP type technologies, those are mission critical because if those go down, your business really isn't that function that well. In contrast, what we consider business critical are workloads where if something goes down, your company's still going to run, but it's not going to run as efficiently. So things I would categorize as business critical would be things like some of the reporting tools you have in place and maybe some of the analytics you have in place as well. Again, these are workloads you need to have. They will not make business big with them. The important slide is we can't move forward without making sure that we still have the right levels of data protection and data management to make sure that these workloads are protected regardless of what happens in our environments. As far as performance is concerned, this is what we were talking about earlier. One of the most difficult aspects is now that we're going to virtualized environments, we're going to heavy consolidation mode, there's many different types of workloads that enterprises have to deal with today, whether it be ERP that are high and steady or seasonal type workloads where you have very variable workloads based on maybe it's an accounting job that runs every month or maybe it's an end of quarter type of thing. And you still have to manage these things together with new and emerging things like test and dev workloads and also hypergrowth type workloads. The hardest part about this is performance requirements rarely stay static. Your storage really has to be able to have the ability to adapt to changed needs. And part of that way we get to that is by introducing new technologies like all-flash arrays, where we just have so much more higher performance capabilities at our fingertips, and we have the overhead and the capability to be able to manage these workloads simultaneously without having to worry about systems getting drowned out because they don't have enough performance. Another key thing to look at is, you really have to talk with your stakeholders to make sure you understand what exactly their workloads will require, both today and tomorrow. So that's the way you can get a more realistic view of if your storage can really handle what's happening today, and make sure that it can still handle things when you wind up having a spike of workloads that may be unexpected. Okay, next section we're going to be talking a little bit about key attributes to look at for flash arrays in terms of some of the functionality and some of the things you're going to want to have as you, if you decide to go down this route of deploying a flash array. Yeah, no secret, if you look at the storage world, storage has always had multiple media types, and usually the trade-off between the media types is cost per gigabyte and capacity, so capacity efficiency versus high performance. If we look at what's been going on in the industry today, flash is gradually moving more and more to the left-hand side from the right. Right now we're already at a point where 15K drives are pretty much obsolete. People aren't looking to use 15K drives to get high performance anymore. The efficiency of 15K drives versus SSDs from a performance standpoint just isn't good enough today, and we're going to be talking about in the next slide. Ultimately, what I wind up seeing is, what we'll wind up seeing in the future is, as flash gets lower in pricing, and as our systems become more efficient at using flash, we should be seeing flash move further and further down the line, eliminating a lot of these other mid-range type hard drive technologies, and really relegating disk and tape storage more towards the archive and long-term data hold type of workloads for unstructured data. This is just to highlight a point. When we look at hard drives versus SSDs, hard drives continue to get more and more less expensive in terms of dollar per gigabyte. All of the innovation that goes into hard drives today are not about performance. It's about adding more spindles. It's adding more bit density. It's all about dropping the cost per gigabyte of that platform. Unfortunately, for hard drives, the performance capabilities of hard drives have not improved in the last 15 years or so since we had 15K drives. So that's where solid-state drives come into play. While solid-state tends to be a little bit more expensive on a dollar per gigabyte basis versus disk, the ability to deliver this high performance with a small number of medium, a small amount of drives, a small amount of SSDs, or a small amount of flash capacity, that is extremely powerful, and that is the main thing that's really driving adoption towards flash. Especially the numbers we have here are a little bit outdated. These numbers on the solid-state disk side were really more looking at things in terms of SLC, single-level cell media. But now that we've gone to other media choices, such as multi-level cell and ultimately to TLC, triple-level cell media, these prices are going to continue to drop further and further, and the target opportunity for flash is just going to get larger and larger in the next couple of years. So as far as elaborating a little bit more on this, one of the first things we see in terms of why prices are dropping so rapidly, it was just not too long ago where we were seeing $20, $30 per gigabytes for a flash array. Now we're seeing prices closer to $2 a gigabyte for flash arrays. A big part of this disruption has been because we've moved to new levels of flash, going from single-level cell to multi-level cell to triple-level cell and even 3D NAND, where we're starting to see more and more the ability to cram more and more data into the flash form factor. The other thing to keep in mind is the advanced array functionality that's being introduced to boost efficiency. So that includes things like inline deduplication and compression, and classic technologies such as thin provisioning, to make sure that you're only allocating storage actually when it's being used, which is another powerful thing, as well as snapshots and clones to boost the overall efficiency of your environments. In terms of flash SSDs, we're seeing very high adoption rates for SSDs going forward, and this should only continue to expand in the near future. Not very surprising. There's a lot of verticals such as healthcare and financial services where there's a relatively high amount of customers that are looking to deploy it or who have already deployed it, and even more that are interested in deploying it in the near future. Again, when we're looking at all-flash arrays should have a lot of the functionality that you have, or should have all the functionality you expect to have in most conventional disk-based systems. In terms of the capacity optimization, we talked about this earlier, but deduplication and compression are very important because flash in general is still slightly expensive media, but by getting deduplication and compression, you can wind up getting more and more capacity efficiency into the environment, and that becomes very important going forward for lowering cost. Another key aspect to look at is management optimization. More and more, these flash systems need to be tightly integrated with cloud environments and virtualization environments, because right now customers are suffering with solid environments where the storage team doesn't necessarily talk to the virtualization team as much as they should, and as a result, it takes longer to provision resources and also takes longer to resolve problems. So that's another key area where we're seeing vendors innovating on the flash array side by doing a tighter integration with VMware and the other hypervisor-type platforms. Another key aspect in terms of architectures, definitely one thing to look at for sure if you're evaluating many of the players out there today is the difference between scale-up and scale-out capabilities. Scale-up simply is vertical scaling. It's adding more flash shells to existing controllers to expand capacity. While this is a nice way for doing this, for adding capacity inexpensively, it doesn't add performance because performance is usually bound by the controller units, which have the CPUs and RAM, and I/O modules to move the data from storage systems to servers. In contrast, a new architecture, and probably more important architecture going forward, is going to be scale-out architectures, which are horizontal scaling. In this case, you're not just adding shelves to the mix, you're adding controller nodes and shelves together so you can add both performance and capacity at the same time. And really the key aspect about this is you're adding these nodes together while still maintaining the view of a single logical system, which is great because then you could have more simplified management while still getting this elasticity and scalability, to increase your performance capacity when you need it. Okay, finally we're going to go into the recommendations section, and after that I'm going to be turning it over. As far as recommendations go, definitely we encourage customers organizations to try to enhance your performance and consistency using Flash. Flash is just superior to hard drives in terms of performance, especially on a consistency basis. So it's definitely, now is the right time to look at Flash. Flash is not just a luxury item, for deep-pocketed enterprises and vertical use cases. It's really ready for the mainstream today. Again, definitely if you're looking to upgrade to Flash, you need to evaluate the vendors and make sure that they have the enterprise-class storage functionality that you require to run your business in an efficient manner and a resilient manner. And finally, we definitely need to focus on the fact that the benefits of Flash are going to extend beyond the data center, and this is what we're going to talk about in a slide or two. When we look at the IT infrastructure benefits, there's a lot of key things where you could see cost savings from Flash. You having the high performance of Flash on the application level is going to allow you to do less tuning, and you'll potentially see a reduction in software licenses. Usually when we talk about the reduction of software licenses, that's usually in the database world. For a long time, because storage hasn't been fast enough, a lot of people have compensated by buying bigger and bigger database servers, and because database servers are licensed by cores and processors, you wind up spending so much money of that database license trying to create buffers on these servers. With Flash, you don't need to have as much of a buffer, so hopefully you'll be able to reduce the number of processors in your applications by leveraging more of the performance of Flash instead of relying on RAM caching. For servers, servers again, ultimately you can get lower cores and less RAM because you don't have to buffer as much, which is pretty similar to what we're talking about in applications. From a storage point of view, the really powerful part about Flash as opposed to disk systems is workload consolidation. While you can consolidate workloads on hybrid storage systems and on traditional disk storage systems, because they just don't have as much performance capabilities as all Flash systems, it becomes much more of a risky proposition because if something spikes up within a hybrid system or a disk-heavy system, your ability to react in terms of your performance capabilities is going to be compromised. So that's definitely an area where we're starting to see flash become a big driver for consolidation within infrastructures. Another key aspect is maintenance. It only takes a couple of SSDs to deliver the same performance as dozens of hard drives. And because of that, you have less things that are going to fail, and also since SSDs are not physical devices, the reliability of the system should be high as well. And finally, when you look at facilities, by saving rack space and by saving power consumption, you could also have another good. You also have a strong ability to be able to take advantage of these things, take advantage of flash, to create more of a savings within your data center. Looking at some of the business benefits, from an application standpoint, having the high performance on the application side is going to allow you to get higher transaction output and reduce latency, which is going to be good for making sure your business runs in an optimal fashion. Again, if you're looking at things like VDI and some of the developer type-oriented workloads, by having an accelerated environment with all flash, you can save worker time and you can avoid the cost avoidance of having to add additional staff and by boosting their efficiency. From a compliance standpoint, we've seen this a couple of times with financial services, but not having enough performance can be very, very bad for them, because if they don't meet their SLAs, they wind up paying big penalties. So compliance is going to be more and more of a driver for all flash arrays going forward, because a lot of companies are struggling to get their work done within the span of a day. Another key aspect, looking at the analytics, one of the best things about flash is being able to run these things so quickly. It'll allow you to have more opportunities to run and test new theses on your analytics platforms and make sure that you're using the data to full extent. And with that, thanks a lot for your time today. I'm going to be turning it over to Kevin Ariel.
Thanks, Henry. Now let's turn to Shahal to hear what is Kaminario's take. Shahal?
Okay, thank you, Shai. Can you see my screen?
Yes.
Okay, very good. My name is Shahal Feinblad. I'm the CTO in Kaminario. I will start with our mission as a company. As a company, we realize that there are storage solutions that are cost efficient, and there are storage solutions that are scalable. But we found that there are no product that is doing both. This is why we took this important mission. I would like to touch on flash technologies. And there are a few important trends that I would like you to be aware of. And these trends will really impact the adoption of all-flash array. What we see is that SSD capacity and costs improve even faster than Moore's law, and in practice faster than HDD and DRAM density. This actually introduced a real opportunity for running more workload on flash. Products that were architected to adopt these high-dense SSD will lead the market in our mind. And actually, we truly believe that Kaminario K22 architectures fit well for these SSDs. And the reason is that it combines flexibility in density together with scalable performance and the enterprise feature. Let's look at main two requirements from any storage system: performance and capacity. On the left side, you can see a typical scale-up system. As Henry was mentioning, a scale-up system is a system that contains two controllers and can scale capacity until some certain limit. But it's not possible to scale performance, but because the performance of the system is limited by the performance that two controller can supply. The other architecture we see by other storage system is a scale-out architecture. In scale-out architecture, we normally see that such solutions scale capacity and performance together. So whenever adding additional capacity, it comes with additional processing power. And this architecture is very scalable, very good performance, but the main issue is that these architectures tend to be more expensive than scale-up systems. And if we look at typical customer requirement, we see that for this specific example, a single scale-up system cannot meet the customer requirement. And in this specific example, a customer will need to buy at least two systems. And two systems means additional overhead of management, data reduction that is less optimized because, for instance, deduplication is not globally across two systems. For this customer, a typical scale-out system can meet his capacity and performance requirement using a single system. This is done by over-provisioning performance. Over-provisioning performance means that in order to meet capacity requirement, a customer will need to buy more servers, and the issue is that it comes with additional costs that many customers do not want to put the extra premium. And we in Kaminario believe in a system that can meet customer performance and capacity requirement in the most cost-efficient way. And we actually built a system that can cover the entire blue area of this graph. At the day of the purchase, the customer will buy a system that meets his immediate goals. And the customer will have a true flexibility to scale performance or capacity according to future needs. So let's look at Kaminario K2 architecture. So Kaminario system is built from a basic building block, which is called a K block. A K block is a component that is using only off-the-shelf enterprise hardware. We do not believe in proprietary hardware. So a K block includes two nodes, two Intel servers, and external connectivity. Customer can choose between fiber channel and SCSI, and you can attach a SSD shelf. In this, the minimum is a single shelf, and it's possible to scale up by attaching a shelf to the existing cable. Now, so a customer can start with his requirement, and later it might need additional performance. So additional performance is introduced by attaching additional cable block to the system of course, everything is done when the system is online. So when adding the second K block, we are also adding internal InfiniBand network, and system automatically balance all the load across both K blocks. All the volumes, the data, and the metadata is rebalanced and fully distributed across all SSDs in both K blocks. And of course, connectivity to the system is fully active. Later, it's possible that the customer will need additional capacity. And in many cases, customers will be very satisfied with the performance. In this case, we will suggest to scale up, to not overspend on buying additional servers, additional processing, but attaching additional storage to the existing K block. And of course, the data, the metadata is fully balanced across all SSDs in both K blocks and both shelves in both K blocks. So, so this architecture allows to start small and grow. And of course, everything is fully distributed. Having everything fully distributed is also important when you deal with flash media, because the endurance is fully distributed across all SSDs in all K blocks. Of course, the ability to scale up and scale out gives the customer the full flexibility to use high density and get to very low cost per gigabyte. A year ago, we announced $2 per gigabyte. We were the first to announce this cost. And this year, we plan, we actually see that the average for Caminario customers will go down to slightly below, actually slightly above $1 per gig. And in some scenarios, it can be even below $1 per gig. Of course, it's all about flexibility. So a customer doesn't really know what will be the requirement a year from now, 2 years from now, and 5 years from now. And we believe in a system which is actually a cluster that remain online forever. So you start with your requirements, and you can scale, and you have the flexibility to scale according to capacity and performance requirements. So from a single block with one shelf, you can scale up by attaching additional shelf, and you can scale out by adding additional K blocks with processing power. And of course, from there you can add additional shelves or additional K blocks, and you can continue to scale out and meet any performance and requirement need. And everything is done while the system is online servicing I/O with high performance. Now, as I mentioned, it is important to be very optimized for the high dense SSDs and for the new flash technologies. TLC, 3D NAND, We are actually the first vendor to support 3D NAND, and we support it for the past 7 months. And we are planning to support TLC later this year, actually 3D TLC. And in order to do it, you need to treat flash right. It's not just replacements of disks. And there are few important things that need to be done in order to be able to utilize a flash technology that is cost efficient. So the first thing is to make the flash array application layer aware of flash. So things that we are doing and we believe are a must for any all-flash array is to always write full stripes and write in a way that is optimized to the flash array. And these equation streams means low write amplification. Now, as I mentioned before, we balance the load across all SSDs. If you are not doing it, you can just use one SSD too much and meet the endurance limits of the drive. This is why it is critical to balance the load evenly across all SSDs. And of course, as Henry mentioned, inline data reduction is important both from cost, so it really reduces the price of effective capacity. And also, since we are using inline data reduction, it means that it also further reduces the write amplification of the SSDs. This is very critical when using 3D NAND, TLC, and this is the way to bring flash technology to a price which is in many cases lower than HDDs. And as we actually, as I demonstrate in the second slide, the density of the SSDs increase very, very rapid, much faster than DRAM density and HDD density, and the architecture should fit to use these SSDs. And we are doing two important things in order to be able to utilize these high-density SSDs today and be ready to even much higher density 4 terabyte SSDs, 8 terabyte SSDs, and even 16 terabyte SSDs in the next few years. So we use a unique patent which is our adaptive block size architecture, which significantly lower the metadata footprint. And an important thing, since the density of the SSDs increased much faster than the density of DRAM, we do not assume that all metadata fits into DRAM. If you do it, it means that the architecture is limited in the ability to utilize high-density drives. And why is that? Because with all-flash array and data reduction, you need to manage much more metadata, and you don't want the density of the system to be limited by the amount of DRAM that you can attach into a server. So I would like to summarize that are unique about Caminario and why we fit well to these trends. The first item that I already covered is our flexi-scale architecture that is the only architecture that allows scale up and scale out flexibility. Easy, the first important thing is consistency in performance. For any load, the system must deliver consistent performance. Easy to scale, everything is done non-disruptively. On cost, the fact that we are able to utilize cost-efficient and high-density SSDs. Last year we announced $2 per gig, and this year we will go down to slightly above $1.2 per gig on average. And of course this comes with our advanced data reduction, compression, and deduplication. And of course we are dealing with storage. As Henry said, enterprise features are mass, snapshot, replication, high resiliency for multiple simultaneous failures. And we actually built an architecture with the same resiliency for small and large systems. Thank you.
Thanks, Shachar. We'll move on to answer some of the questions we got from the crowd. The first question is for Henry. So Henry, how are enterprises justifying their flash array purchases?
Yeah, today I think a lot of times it depends on who you're talking to at the enterprise. When we look at things from the infrastructure level, a lot of them are looking at the metrics I showed earlier in the presentation in terms of they're looking at rack space, they're looking at power, they're looking at application efficiency and what it can do to the efficiency of servers. But ultimately, I think that's what we do in the early stages. Going forward, we're really going to have to get more business value out of acquisitions, out of these technology acquisitions. So from that perspective, I think customers are going to look more and more at what Flash can do in terms of helping you with your workers' productivity and also with the productivity of your applications, and potentially looking at other metrics, as I mentioned earlier, like SLAs, like making sure that you can meet your SLAs so you don't have to pay penalties, and so you can ensure that you have a strong customer experience.
Okay, thanks. Here's one question for Shachar. Shachar, when do you see TLC and 3D NAND combined in the Caminario product?
This is a good question. We actually used 3D MLC SSDs for the past 7 months, and we are very active in testing 3D TLC SSDs, and we are actually planning to support them this year. Something interesting about the TLC SSDs that we are testing, these SSDs come with similar endurance to the 16 nanometer MLC SSDs that other vendors use, and actually these 3D TLC SSDs are coming with similar endurance and much better cost and much better density.
Okay, so I guess the next question will be also directed to you. What would be the downside of using TLC in the Caminario product?
Okay, all flash array should be optimized for flash. And actually this is a very good question, because an all-flash array should be built and architected when looking at the future. In order to be cost efficient, you need to use the same flash media as in any iPhone. In practice, we added few critical optimization. As I mentioned in my presentation, we are balancing the load evenly across all SSDs, and we are writing to the SSDs in a very optimized way. And since we use inline data reduction like compression and deduplication, we actually write less to the SSDs. And this allows to use very optimized architecture and not overspend on very expensive SSDs. In practice, all these optimizations are critical in order to utilize the new 3D TLC SSDs that are available today. And it's even more important for utilizing the future array that we see with 8 terabyte, 4 terabyte, and even 16 terabyte. And we will deliver these benefits for our customers. And the game here is to allow customers to benefit from Flash for more workloads, for more application, and gain a real business value in a very cost-efficient way.
Okay, thanks. Henry, that one is for you. What other value can flash arrays bring beyond raw performance?
Yeah, I think really that's a misconception about Flash. People think about Flash and they automatically think raw performance and top-line performance, when I think really the strongest value of Flash isn't the ability to do hundreds of thousands of IOPS. Within an organization, you may have a couple applications that may need lots and lots of IOPS at any given time or transaction performance at any given time, but really to me the hard part that customers have today, and especially where they struggle with disk-based systems, is consistency of performance. So it's not so much being able to deliver lots of performance for one application, it's being able to make sure that if you have 5 or 6 or 7 applications running on an array, that the various spike ups you may have in those applications don't affect each other, because you should have enough performance to be able to spread that out and to be able to adequately distribute performance. So it's more about performance granularity and efficiency more than just straight top-line performance. So that to me is the big value there. Also, as we talked about earlier, there is big values in terms of what can it do for your data center itself, in terms of rack space efficiency, in terms of power consumption and other aspects like that, in addition to a reduction in maintenance costs, since you have less things that could potentially fail.
Okay, thanks. Another one from the crowd, Shachal. What is the one thing that a customer can do right away in order to implement all-flash arrays?
This is actually easy. An all-flash array supports the same protocol like legacy array. And with an all-flash array like Caminario K2, you need to just attach the new K2 system to the application. Very easy. And you immediately gain the value in performance. You don't need to do any optimization. And in practice, in less than 4 hours, we can install a system and customer can start using it. Everything is easier with Flash, and there is no need to define millions of things. Creating a volume is just, you need to mention the size of the volume, and everything is done automatically, and it's easy.
Okay. So the following question I think is relevant, and it will continue the same line of thought. It will go to Henry. Henry, what would be the best workloads to target for all-flash arrays?
Yeah, I think really the starting point we usually see for workloads is they start attacking some of the things that are very I/O intensive. So some of the early use cases that focused on VDI and server virtualization. We've also seen a lot of customers looking at this for applications such as databases, where transaction performance is very important. But I think really when we look at flash technologies, again, the point I want to emphasize is it's not a vertical technology anymore. It shouldn't just be focused on high performance use cases. I think because of the price differentials we're starting to see and the increase in efficiency, now is the right time to start looking at flash for other use cases, because what you can get in terms of benefits beyond performance can make it very powerful in other use cases that aren't just all about transactions.
Okay. Thank you. So I think we have time for just one more question. So the questions that went unanswered, we will make sure to follow up with you guys. So Shahal, the last question is directed to you. What is different between Caminario and other all-flash array solutions?
Good question. The main differentiation is actually the mission we took, to enable customers to scale their business easily and cost efficiently. As I described in my presentation, we build an array that can scale up and scale out, and by doing that, we can scale to any customer requirement in the most cost-efficient way. We also introduced advanced enterprise features that are critical for any storage customer, and advanced data reduction functionality that brings the costs. These functionalities allows customers to make storage easy and cost efficient. We announced an average cost of $2 per gig a year ago, and this year we expect to see the average go down to close to $1 per gig. So to summarize, the combination of scalability and cost efficiency really differentiates us from all other all-flash arrays.
Okay, thanks for that. Thank you, Henry, as well. I guess our time is up, so I would like to personally thank all of you for participating in this webinar. And I invite you to visit us on our website, caminario.com, for more information. And have a good weekend. Thank you very much.
Thank you.
Thank you.
Bye-bye.